Hi, my name is Piotr Skowron, and in this talk I'm going to discuss committee elections, also referred to as multi-binary elections, a topic that I'm recently mainly interested in. The topic of committee elections is set in the field of computational social choice, which is an area at the intersection of economics, computer science, and mathematics. Computational social choice deals with the following problem. We have a set of individuals who might have very different preferences, and our goal is to aggregate these preferences in order to achieve a certain goal. For instance, in order to select a certain outcome. In this talk, I will first introduce the model of committee elections. Clearly, this model is interesting to people who study social choice, for instance, to those who design elections. But I will also argue that this model and these types of problems that appear in committee elections are interesting to us as computer scientists. The first way in which I am going to argue that is based on applications. I will show that certain tools from social choice can be successfully used in order to achieve a certain goal or to improve certain qualities of mechanisms which are strictly set in computer science. Second, I'm going to discuss conceptual and technical challenges that appear in the analysis of committee elections. And here I will mainly focus on the concept of proportionality. Next, my goal would be to go back to the initial question of why computational social choice is interesting to to computer science in general and artificial intelligence in particular. And these types of arguments, which I'm going to use next, are based on techniques. So I will explain that the techniques that origin in computer science can be successfully applied in order to achieve a better understanding of social choice mechanisms. Finally, I'm going to conclude this talk by discussing certain potential directions in which we could further move the integration between the field of computational social choice and the other fields of artificial intelligence. The model of committee elections consists of the set of candidates. Here they will be represented as these cartoon figures. We have also the set of voters, and the voters have preferences over the candidates. In this example, these preferences are approval-based. That is, each voter approves a certain subset of candidates. The first candidate approves 5 candidates here. The second voter approves 3 candidates, the pink, the green, and the orange one. The third voter approves 2 candidates, and so on and so forth. Based on those preferences, our goal is to select a fixed size subset of candidates called a committee. And the committee rule is a function that maps candidates, voters, and preferences over the candidates into an outcome, in this particular context, the committee. Electing a representative body such as a parliament is perhaps the most classic example where committee election rules are used. However, committee elections appear also in other contexts. For example, selecting winners in a competition is in fact an instance of committee elections. Here, candidates are contestants, or for instance, grant applications from which we need to choose those that will be qualified for funding. The voters in these examples would be judges or experts who express their opinions over the qualities of contestants or grant applications respectively. The problem of choosing allocations of public facilities is in fact also an instance of committee elections. Here the candidates are the potential locations of the facilities, and the voters are the potential users of the facilities, which who might have preferences over where the facilities should be built. Now let's have a look at a seemingly very different scenario. Assume that our goal is to design a search engine that, in response to a query, returns a ranked subset of objects, in this case, a ranked subset of images. So this search engine, when receiving a query, in fact needs to solve a social choice problem. The voters are the potential users of a search engine, which might have different preferences with respect to which items should be presented in response to their query. The candidates are different types of responses to the query. The only difference is that a search engine returns a ranking over the images rather than a fixed size subset of images. But this difference is very small. We can interpret a ranking of objects as a collection of committees where each committee corresponds to a prefix of a ranking. So let's have a look at this screenshot, which I made a couple of days ago. And it represents a response to a query Apple returned by Google search engine. So we can see that in the first 6 items returned by this search engine depicts images of logos of the computer company. The next 2 images correspond to fruits. And somewhere later in this ranking, we can see also images of devices produced by the Apple company. Thus, this diversity in this search result suggests that possibly there are different types of users who might have different idea what kind of images should be returned in response to the query Apple. Thus, we can see that this ranking, in some sense, tries to take into account these different types of users. If we take a look at the first 8 items returned by this returned in this put in this ranking, that we can see that those items somehow proportionally represent the different types of users, the different types of potential users of the search engine. Thus, we can see that here, in fact, a search engine is trying to solve a very similar problem that we face when electing a parliament, where our goal is to select a subset of candidates that also proportionally represents the voters. This suggests that our knowledge from social choice can be successfully maybe used in certain applications which are set in the field of computer science. Another example which is set in the computer science, in the field of computer science, corresponds to consensus protocols, such as the blockchain. Sometimes within these protocols, for the sake of efficiency, one needs to select a subset of users who will act as validators. Those validators should be selected based on the trust that is laid in these candidates from other users. The relation of trusting can be also viewed as a type of a preference, like approving. In fact, selecting validators based on the preferences of users and based on their trust can be represented as an instance of committee elections. The final example that I would like to mention within this talk refers to participatory budgeting. So in participatory budgeting, the setting is slightly different. We have a set of projects, but these projects have also their costs. And the goal is to, based on the preferences of voters, in this particular example, citizens, to select a subset of projects which do such that their cost does not exceed the predefined budget. These scenarios, so participatory budgeting is getting more and more popular, mainly because of more and more funds devoted to this idea. For example, in the city of Paris, since 2016, more than 100 million euros is devoted to the projects for funding projects within participatory budgeting. Okay, so we have seen that, so what I've tried to argue is that the model and the ideas from social choice are interesting to us, computer scientists, because these ideas very often appear also in settings which are not related to social choice per se, but which have which are strictly in which are strictly set in the field of computer science. What I would like to also argue is that there is also a direction, there is also a flow of ideas in the other direction. That is, the techniques that origin in computer science can be successfully used to design better social choice mechanisms. Okay, but one can ask, why shall we study and why shall we aim at designing good mechanisms for electing committees, for participatory budgeting? These problems are appear in practice and they are solved in practice. So in fact, it seems that we have quite a good set of tools that already exist, that are already used, and that could be applied successfully in different settings. So the answer is that, in fact, this is true. We have a quite rich set of tools, quite a rich set of election rules that could be used. However, all these rules and all these tools that are mostly used in practice are imperfect and in fact have very bad properties. I will explain that on two examples. The first example refers to participatory budgeting. So imagine that we have such a city where this city is divided into 4 districts: north side, south side, west side, and east side. And let's assume that each district is roughly of the same size. North side is slightly larger than the other 3 districts. Let's further assume that we have a total budget of $400,000 to spend on the projects. These projects are marked with capital letters, and next to each project we have a total amount of money that would be needed for this project to be implemented. Okay. So how could we solve this problem, and how could we select the projects for funding? One approach which is typically used is to ask the voters to approve projects they like, and then select those projects which are approved by most voters, and to select them sequentially until the budget is the whole budget is used. Now assume that the voters' preferences are very local. Let's assume that the voters only approve the candidates, the projects that are in their districts. For instance, all the voters in the north side approve projects A, B, C, and D, and no other projects. So how would this approach work in this particular case? Here, the projects that will be selected would be A, B, C, D, F, and I. So we can see that almost entirely, that almost all projects that have been selected come from the north side, and only two very small and very cheap projects from the east side have been founded. So you can see that this rule is in fact very disproportional, is very unfair to the voters. The projects from the west side, the voters from the west side, and the voters from the south side, and in fact, even the voters from the east side have been completely ignored by this rule. So another approach, in fact, this problem has been identified. And another approach that is sometimes used in practice is to divide the voters into districts and to run an independent election within each district. So, in fact, of course, this solves the previous problem because now the voters in the north side, they will have only $120,000 to spend on their projects, and the way in which this amount of money will be divided between the projects will depend on the preferences. But the voters from the west side and the voters from the south side will also have the budget, the amount of money proportional to their size that they would be able to decide about. Okay, this solves this problem. However, different types of problems appear. The first type of problem is that it is not possible to fund a project that are interesting to whole citizens of the city. For example, let's assume that there is a group of cyclists that they would like to fund a project and building a new cycling route along the example river. It would be not possible for them because they come from different districts to realize these projects. Or let's assume that there are parents who would all like to have a large playground in the city, let's say Project C. And within this approach, the Project C could not be funded because it's too expensive, even though maybe voters from the other districts would also like to this project to be implemented, to be built. Another type of the problem that appears here is that the projects which are close to the border might be interesting not only to the districts in which they are, but also to the neighboring district. For instance, here, Project A, it could be interesting not only to the voters to the citizens from the north side, but maybe also the citizens from the west side would like to vote for this project, and they are not allowed to do that. Thus, we would like to rather to have a mechanism that allows to vote the voters to vote on different types of the projects, both global and both local, and that would be fair at the same time. And we would like it to be fair, to be proportional, not only with respect to the geographic districts that appear, the geographic locations of the voters, but in a way we would like that each interest group within the city should be represented, should have a right to make a project that they like funded. For instance, the dock owners should be able to found a project, to make a project which is good from their perspective to be funded, but also cyclists and so on and so forth. The second example that I would like to mention is an example of electing a representative body such as parliament. So one could argue that parliamentary elections are carried out worldwide, thus there exist known practical methods for electing committees in this context, which are also proportional. This is partially true, but let's have a look at how these voting systems are usually implemented. It is typical to assume that the voters vote not for candidates but for political parties. These systems are really indeed proportional in the sense that each political party gets a number of seats in the parliament, which is proportional to the number of votes cast for this party. However, this is a source of certain problems. In particular, the voters cannot vote for individual candidates, and thus the candidates feel more obliged to political parties rather than to the voters. Another way in which parliamentary elections are carried out is through voting-based districts. In this case, in this example, in this case, the voters are divided into districts, and a separate election is carried out within each district. However, this system might not be proportional. For example, let's assume that there are three main ideas in the society, which are depicted in this example by three colors: the green one, the red one, and the orange one. And let's assume that within each district, there's a majority of voters, there's a slight majority of voters who represent the green idea and thus vote for candidates representing this idea as well. Then if we run independent elections in each of these districts, then in each of them we would select a green candidate. But this result would be clearly not proportional, since roughly 1/3 of the society likes the red idea, that the red candidate should be elected, and similarly, roughly 1/3 of the society likes the orange idea, that this candidate should also have a spot in the elected committee. Okay, so we would like to have a rule where the voters can vote for candidates, not for political parties, and that is proportional. But what does it really mean to be proportional? So let's start from looking at a very simple example. At an election where we have 8 voters and 9 candidates, the first 4 voters approve of 4 candidates: the green, the red, the light green, and the blue one. The next 2 voters approve 3 candidates, and the next 2 voters approve 2 candidates. So let's try to see what is our intuition. Which committee would be proportional in this case? So first we can observe that in fact we can divide these voters and these candidates into groups, into separate groups, such that the voters within one group approve only candidates from one set, from their group, and not the other candidates. And thus we can see that in fact this election, this instance of an election has a very specific structure. This structure allows us to identify a proportional outcome rather naturally. So we can see that we can elect from each group, select from each group the number of candidates that is proportional to the size of this group. So for instance, a proportional outcome, for example, would be to pick 2 candidates, let's say the green one and the red one from the first group, 1 candidate from the second group, and 1 candidate from the third group. Okay, so in this example, when this structure of the preferences was rather easy, we were able to clearly identify a proportional outcome. However, what happens if the preferences are more complex, and where it is not possible to divide the voters and the candidates into such nicely aligned groups? Which committee would be proportional in this case? This question is much more challenging, both conceptually and technically. A number of approaches have been applied to reason about proportionality. One such approach is based on identifying an axioms that would properties that would formally capture the idea of the high-level idea of proportionality, and then examining rules with respect to whether they satisfy these axioms or not. So for instance, let's look at this group of voters, this group of two voters that consists of voter V3 and V4. So we can see here that those voters, they form 1/4 of the society, and if the size of the committee to be elected is also 4, then it seems that these voters should have a right to select at least one candidate. And in fact, we can see that they all agree that the green lady is acceptable. So the intuition here is that at least one of those two voters should have in the elected committee at least one representative. Because otherwise, if those two voters had no candidates that they approve in the elected committee, then they should have a right to leave the society and to elect this one candidate on their own, since they form a group of a sufficient size to be able to elect one candidate. Similarly, we can see that this group of 4 voters, they form half of the society, and in fact, we can see that those voters agree on 2 candidates, on the purple and light green candidates. So here the intuition would be very similar, that one of those voters, one of those 4 voters should have at least 2 candidates in the, should approve at least 2 candidates in the elected committee, because otherwise these voters could form a coalition which could have a right to deviate from the society and to elect their candidates on their own. We can extend this intuition to a formal definition, saying that each group of size at least L times n over k, and we can see that n over k, k is the size of the committee. That means that n is the number of voters. So n over k means that this is a group of voters that should be eligible to elect one representative to the committee. So if a group has size L times n over k, and if they agree on some L candidates that they like, that they find them acceptable, then at least one of those voters should approve at least L candidates in the elected committee. This property is called extended justified representation. And surprisingly, there are very few rules known which satisfy this property. In fact, there are only 2 natural rules which are known. So why will we mention one of those rules which we proposed with Dominic Peters in last year. And I will specifically focus on these rules because these rules also extend to this more complex setting of participatory budgeting that I mentioned before. According to our rule, each voter is initially given some amount of virtual money. Let's say that he's given K dollars. Buying a candidate costs N dollars, where N is the number of voters. And we assume that this cost of buying a candidate is spread equally among the voters who approve this candidate and who still have money. Formally, we find a minimal price such that if each voter who approves this candidate C pays this minimal price, or all the remaining money that she has in the pocket, then the candidate C gets N dollars in total, and thus will be bought into the committee. Once we find such a minimal price for which we can find such a candidate, then we add this candidate to the committee and proceed with the rule. So let's look how this rule would work on the following example. Let's assume that we have 6 voters and 12 candidates. And here the candidates are represented as boxes with the intuition that a voter approves all candidates whose corresponding boxes are above this voter. Let's assume that the size of the committee to be elected here equals k equal 12. So first, the minimal price for which the candidate can be bought equals 2. Indeed, for $2, if each of the first three voters spends $2 on candidate C1, then this candidate will get in total $6, which is the amount that is required to for a candidate to be included in a committee. So for this price, C1 is selected. For the same price, those voters still have money because initially they were given $12. So they can also, for the same price, buy candidate C2, C3, and so on. And next, the price is raised, and for $6, each voter can afford to buy a candidate who is approved only by this single voter. So after all the steps of this rule, the committee will be elected that is marked with the blue color in the left part of the figure. So initially, the intuition is the following: that this rule is fair, is proportional, because each voter is initially given the same number of virtual coins, and these coins, in some sense, represent the power of the voter. This rule also satisfies the axiom of extended justified representation that I mentioned before. So this is one of the ways in which we can reason about voting rules, the axiomatic approach, and often the techniques which are used in this approach are very combinatorial and very similar to the techniques used in the analysis of the algorithms. In particular, a lot of ideas are inspired from the analysis of approximation algorithms. Yet another approach that I would like to mention is based on experiments. In this approach, we assume that voters and candidates can be represented as points in the ideological space, issue space. In this example, this is a two-dimensional Euclidean space. So we draw the voters and the candidates from one of the three distributions depicted in the slide. Once we draw the voters and the candidates, we construct an election, select a committee according to a given committee election rule, and mark the candidates within the committee with a blue color. We repeat this procedure many, many times, and we put all these blue spots that correspond to elected committee members on one histogram. As a result, for example, for one of the voting rules, we get the following histograms. What is the interpretation of these histograms? The intensity of a blue color of a given point corresponds to the probability that a candidate who is in this point is selected to the winning committee. So we can see in particular that this voting rule here creates committees which are very proportional, because the distribution of committee members very closely reflect the distribution from which we selected candidates and voters. However, this is not the case for all voting rules. Here, each column corresponds to one voting rule. And for instance, we can see that the second voting rule that we considered creates much more centric committees. Further, other voting rules exhibit very strange behaviors, which we can observe, for instance, in the example of the third rule. So this approach allows us to give some intuitive understanding of what do committee election rules do, at least under the assumption that voters and the candidates all come from the distribution, all can be represented as points in the 2D Euclidean space. So let me summarize this talk. I've argued that computational social choice in general and committee elections in particular are interesting to computer science. First, they are interesting because the tools which are well established in social choice can be successfully used in problems which are set in the domains typical for computer science. Second, they are interesting because the techniques that origin in computer science can be successfully used in the analysis of committee election rules. And as a result, they can also lead to creating new election rules and new other tools which are superior to the known existing mechanisms. And I would like to conclude with discussing my hope, with expressing my hope that we can further integrate computer science in general, the other parts of artificial intelligence with computational social choice. In particular, in computational social choice, it is very hard to perform an analysis of the behavior of different rules and different mechanisms, assuming some behavior of the voters, because the behavior of the voters of humans is very hard to capture in formal models. So my hope is that the recent advancement in different methods in different areas of artificial intelligence will allow us to construct more convincing models capturing humans' behaviors and to analyze different voting rules with respect to these models. Last but not least, I'd like to say that the whole advancement in the field was only possible thanks to wonderful people involved in computational and social choice, involved in the research and in building this environment. Here I listed my co-authors and people that I owe most. Thank you very much.